Dear students, welcome to our science episodes. Today we are going to discuss chemical equations and chemical reactions. Chemical equation and chemical reactions. We will start with this activity. We will try to burn a magnesium ribbon in air. Try to hold a magnesium ribbon with a tongue over a flame. It will burn in air or in oxygen. What is your observation? You will find that the magnesium will change from a bendable bright solid into white powder. And this is as a result of the heat that has broken the double covalent bond in the oxygen molecule and turn it into chemically active two oxygen atoms. These oxygen atoms will combine together with the magnesium atoms, forming a molecule of magnesium oxide. If we will represent this with a diagram, here is the magnesium atom and the oxygen atom. Magnesium is a metal and oxygen is a non-metal. So magnesium will lose electrons for oxygen to gain them and forming ionic bond between the two elements. As we said, magnesium is a metal. It loses 2 electrons from the outer shell, forming a positive ion. And oxygen is a non-metal. It will gain 2 electrons, forming a negative ion. They become attached by an ionic bond. Magnesium plus oxygen, by heat, it will give magnesium oxide. So, in a chemical reaction, we can say that there is breaking of the bonds between the atoms of the reactants and formation of new bonds between the atoms of the product. We can define a chemical reaction by breaking the existing bonds between the atoms in the reactant molecules and forming new bonds between the atoms of the product molecules. Importance of chemical reactions. Simply, we can get plenty of necessary substances through chemical reactions. And most of the modern industries depend basically on chemical reactions. For example, fertilizers, car batteries, fuel, plastics, and food industries. Now let's take this example to practice about chemical formula. And the question is, what is meant by number 2 in these chemical formula? 2Na. These are 2 atoms of element sodium without a chemical reaction between them. No chemical reaction between them. Just 2 sodium atoms freely exist. O2. When you put the number after the atom, they are 2 atoms of the same element, but they are attached together. So 2 atoms of oxygen attached together by double covalent bond, because each atom will share 2 electrons with the other atom, forming double covalent bond, forming an oxygen molecule. Another example, Na2O. These are 2 sodium atoms, but they do not freely exist. They will react with an oxygen atom in a chemical reaction. So, 2 sodium atoms reacting with 1 oxygen atom. 2Na2O. 2 sodium oxide molecules. So, if you can notice, the 2 2 sodium oxide. This is the sodium oxide. If we put 2 before this formula, this means that 2 sodium oxides molecules. So 4 sodium atoms will react with 2 oxygen atoms, forming 2 sodium oxide molecules. What about CaOH2, calcium hydroxide? Calcium hydroxide molecules consist of 1 calcium atom and 2 negative atomic hydroxide group. Remember that the hydroxide group is an atomic group. It enters the chemical reaction as a group, not as oxygen and hydrogen alone. So 2 hydroxide groups attached to the calcium by an ionic bond. Now remember that the chemical reaction is represented by a chemical equation. What's a chemical equation? It's a set of symbols and chemical formula representing the reactant and the product molecules in a chemical reaction, and it represents the conditions of the reaction as well. My question for you is, how can a chemical reaction be represented by a chemical equation? Reactants are written to the left of the arrow. So we have reactants and we have products. The reactants are always to the left of the arrow or before the arrow. Products are written to the right of the arrow or after the arrow. So we have reactants and we have products. Conditions required for the reaction, as for example heat, catalyst, are written above the arrow. And the arrow itself shows the direction of the chemical reaction. So this is an arrow. This is the direction of the chemical reaction. So the chemical reaction starts here and ends here. And this triangle over the arrow means heat. A chemical equation is usually written in symbols representing chemical formula. The chemical equation should be balanced. Sodium plus chlorine. These are the reactants. And this is the arrow. And this is the product, sodium chloride. Chlorine is an active gas. Its molecule consists of 2 chlorine atoms attached by a single covalent bond. Let's have a look together on this chlorine molecule. This chlorine molecule consists of 2 chlorine atoms. And they are attached together by 1 covalent bond, single covalent bond, because each atom will share an electron with the other atom. While sodium is a metal, and you know that metals tend to lose an electron, forming a positive ion. So the sodium will lose an electron, which gained by the chlorine, which is the non-metal, to form sodium chloride. But the chlorine molecule consists of 2 chlorine atoms. So actually we need another sodium atom to react with the other chlorine atom. So 2 sodium atoms. Each of them will lose an electron for each chlorine atom to form the sodium chloride. 2 sodium atoms are needed to react with the molecule of chlorine because the molecule of the chlorine consists of 2 chlorine atoms. The equation here will be as following: 2Na, which means 2 sodium atoms, with chlorine molecule Cl2 consisting of 2 chlorine atoms and the arrow, and then the product is 2 molecules of table salt or NaCl. Can you try to guess why it's better to write the chemical equation in symbols using the chemical formula, not in written words. Let's see together. This is the written chemical equation. Sodium plus chlorine equals sodium chloride. But actually, this is the symbolic equation. The symbolic equation will show the type and the number of atoms. So you can, from the symbolic equation, know that in this equation, two single sodium atoms will react with a molecule of chlorine, which consists of two chlorine atoms. And we can represent above the arrow the conditions required for the chemical reaction as well. So generally speaking, the symbolic chemical equation is better than the equation written in words. As we said before, the chemical equation should be balanced. What do we mean by balanced chemical equation? Do you know the balance? The balance that we use to measure the mass of a substance. So, for a balance to be balanced, so the right side should be equal to the left side. It is the same as the chemical equation. A balanced chemical equation means that the left side of the reactant should be equal to the right side of the product. Or in another word, the number of reactant atoms of an element should be equivalent to the number of its atoms produced from the reaction. Example 1. Chlorine plus potassium bromide will give potassium chloride and bromine. If you will see, the reactants here are the chlorine and the potassium bromide. The reaction. First, the single covalent bond between the two chlorine atoms will be broken, and the ionic bond between the potassium and the bromine ions in this molecule will be also broken. Free potassium will then react with the free negative chlorine ion, forming potassium chloride. And the two free bromine atoms will form bromine molecule. As if the chlorine will take the place of the bromine in this compound. So instead of potassium bromide, it will be potassium chloride. And instead of two chlorine atoms forming a chlorine molecule, there will be two bromine atoms forming a bromine molecule. Note that the equation is unbalanced. The bromine here is only one atom, and here it's a molecule formed of two atoms. And here a molecule of chlorine with two atoms of chlorine, and here it's a chlorine ion. Therefore, we need two molecules of potassium bromide to react with the chlorine molecule, which consists of two chlorine atoms, to form two molecules of potassium chloride and a molecule of bromine. Now, if you look to this equation, now it's balanced. Dear students, thank you for watching and see you later in our science episodes.